Thank you. Hello, everybody. I hope that you've got a bit of energy after having lunch and you're not falling asleep. But if you are, I'll wake up for the demo. I'll wake you up. So today we're going to talk about what's the state of machine learning and AI with JavaScript and within browser space. So we will have a bit of overview, but it's going to be very short because I don't have that much time. We go through the what, we review the how, so we're doing a bit of show code snippets and how we do stuff with TensorFlow.js, basically, which is the library Google created at 2018. And then we have a demo, and basically the demo will be us transfer learning a pre-trained model and then use our voice commands to fly that drone. So hopefully that will wake you up. My name is Yas. I'm a lead consultant at TensorFlow, and I do a lot of front-end stuff, and I love web. You can find me at Twitter at YasHints, and that's my website down there. If you go to the blog, you will see a lot of front-endy stuff there. So just a quick overview of machine learning for newbies like me, because I don't have any background in machine learning or data at all. And I just got interested when I found out about TensorFlow.js because I could use it in my day-to-day job. So that's pretty amazing. Now, all that a machine learning model does is like it gets some inputs, and then it goes through a series of layers of basically doing some mathematical operations, and then it gives you an output. So in this case, we are saying, okay, take these two pictures and tell us what it is, and it tells us that that's a dog. Now that's ideal scenario. You will get probably cat for 99% because you haven't used proper data, and that means that data diversity is really important for machine learning, and we'll see why shortly. So basically, we've been doing machine learning for many years, but now the main question is why we're doing it in the browser. What's the difference now? The very first one is, well, if you can run anything on web, it gets a really wide distribution. So a lot of people around the world can basically use it. Previously, if you had a machine learning model that you basically developed, it will be local to you. The way you could basically distribute it is just transfer a bunch of files to someone else, and that was like a one-to-one communication or one-to-many based on how would you distribute that machine learning model. Now with this one, you just basically create your model, you publish it as a NuGet package, and then millions of users can just go download it and use it in basically a matter of minutes. It will give you interactivity. So previously, if you basically were creating a machine learning model, you will have to interact with your model basically through your commands and coding. So what would you do is you basically, let's say you had a Jupyter notebook in instance, you'll basically have to define your steps, run your thing, and then define it again. If you wanted to change something, you will have to change it in the code itself. Now with this one, you have a lot of options, and you could just basically give users interactivity so they can play around with your model however they want without you being involved, which is great. The next one is, well, many of us just use our mobile device for day-to-day operations, whether it's email, whether it's browsing, whether it's texting, Facebooking, I hope not. But anyway, these devices come with a ton of sensors. There are cameras, the microphones, GPS, a lot of different sensors. And what if we could just use that data right there where the user is using it? So one of the very beneficial things with this approach is the data privacy. So data stays on the client. You don't need to collect users' data to be able to run your model. So you've already done your training, for example, and you've published your model. Now the user feeds the data right in their device, and they just get a response back. So you're not involved in collecting any data which you don't need. So everything started from this playground. This is the TensorFlow playground, which they created to let users to be able to play around with one of the models or many different models. And then they realized that if people can interact with the model using this UI, what if we just let it run in the browser or bring it to web? Because that's what all the interactivity happens. And that's how TensorFlow came to life in 2018. You could clap now. Thank you. But basically, what it gives you, it was released in 2018. How it's basically run on WebGL in the browser. So it uses your graphic card. If you don't have a graphic card, it uses your CPU. And even if you have a TPU, in the near future it will support TPU as well. And the wow factor is you could basically run inference and training right there in the browser. We don't have time to do that, but we do basically retrain the model in the demo. So how it works, it's got a bunch of layers. We don't go through all of those, but basically you have 3 layers. You have your model on the top level. That's where you basically interact with the model. That's what you expose to all the users. Underneath the model, there is layers API. So every single, as I showed that picture, you saw those layers. Every single machine learning basically model consists of a lot of, or maybe a few layers. These are basically exposed through layers API. So if you want to go further than what the author has basically exposed to you, you could just use the layers API instead of using the actual model layer. And then there are core APIs, which is used basically to expose the TensorFlow operations in basically to the layers API. So these are sitting on the top. Now, as we mentioned before, you could just use this in the browser, in the web space using WebGL. Or you could use it in Node.js, which is also possible today, and you could utilize those TPU, GPU, and CPU. Now, you might have a question of why we should use it in Node.js if you're talking about web. Well, as I mentioned before, the data is really important in any machine learning model, and data is really large most of the time. So you might have a collection of, for example, 1,000 images. You don't want your users to upload those images and then basically use that in the browser with that limited memory space. So basically you could retrain your model in the server side and then send the result back into the web so they can do the inference part just on the website. Does that make sense? Cool. And then you've got the ability to convert your Keras model or your TensorFlow model into any of those layers that have been mentioned before. So there is a converter which is basically developed by Google. You could use that to convert a TensorFlow model or a Keras model into TensorFlow.js. So there are a lot of pre-trained models put in the examples repo of TensorFlow.js. And you could just go and play around with them. Every single model has the base model in itself, and then there's a demo folder which has a prepared demo for you, and you could just go and download the NuGet packages, run npm install, run npm start, or yarn watch, and then just see what happens and play around with the demos in that space. We do that. I've basically done a few changes to one of those, and we'll see it in a second. So there are different basically types of models exposed there, from PoseNet that detects your poses of your body, from body segmentations, from a speech command where you can play around with the voice where we're doing today, and then a lot of different, just handpicked a few here. So there are a lot of stuff, so definitely go check their repository. Now, how we do it is, this is the most fascinating part. Like when they expose the model through an npm package, all you need to do, for example, to use one of those is this. So you start with basically including that script file in your HTML page if you want to just use HTML, or you could download that install that NuGet package and use that. You might have an image tag, for example. In this instance, I'm using the body pics, which is used for pixelating body parts in a particular photo. And this is the photo I'm using. So this is Ronica, my daughter, which I normally do a lot of practice talks on her. Poor girl. And then you basically load the model. What this does is it just goes into a Google Cloud storage, which is hosted for you for free. Download the model from there, and it's right there ready for you to do any operation you want. Well, in this instance, we just give it that image element, and we say, hey, estimate basically users' body parts in this picture. It gives back a JSON structure. So this is the JSON that you just play around. This is the data part in that particular photo. Now there are other utilities that you could potentially play around with. This one is masking that area that Ronica is staying at the moment, and what you get is basically this. So you could draw that JSON file, fit it into a canvas, and then mask it on top of that photo, so you basically have an idea of what's happening. Now this is just a basic example. There are many real use case scenarios, and the way it's going forward is really fascinating. I'll show you one of these ones. This is called creativity. You see me basically sitting there and playing music with my nose. Now this was designed to get people who don't have hands ability to play music. Now how good is that? Look, imagine the possibility that we could basically open up the web to a lot of different users with different accessibility issues and different use cases. Now this one is really interesting. You could definitely go check out that link. There are a few different examples of the real use cases that Google is using TensorFlow.js, but there are some actually real use cases as well. So Airbnb is using basically in a different scenario. So the first one is they're detecting whether a particular photo is, for example, a bedroom or a kitchen or whatever else in the house. The other one is basically looking for objects. So if a room is furnished, they'll detect the object in that photo using an object detection algorithm. Or even more interesting, if you upload a photo of you as your avatar or as your profile photo, and that photo is taken, for example, from your license, it will show you a very interesting warning and say, hey, this particular photo includes sensitive information. That only works for US for now, but you get the idea, because you could use it in a lot of different ways to do stuff. So how are we going with time? Yeah, we're good. Let's see a demo. Now what I'm doing here is, let me just duplicate my screen with you. So what we're going to do is I've grabbed one of the pre-made demos of speech command, and I've customized it to basically, if I come into TensorFlow.js, so this is the repository that I was talking about, and if I come here and come here into this folder, I can open up VS Code. Everybody loves VS Code, and we should. Now I can come here and basically type and watch. This will run parcel. I'm not going to talk about parcel today. That's a different topic we'll go through later. It's a great bundle, by the way. And it gives me some space to basically waste some time until this kicks off, so it's fine. How are we going, by the way? You feel heavy? You should have Coke. All right. So you have to wait for this, and yeah, the model is now loaded. So what I do here, speech command is a speech recognition model. What it does is they've pre-trained it for a certain words, like up, down, left, right, and it supports maximum of 18 words at the moment with this model. So what I'm demoing now is we're just going to try out a bunch of those commands, and I've converted those commands into emojis, right? Pretty simple, nothing very special about this. Now, later on, we pre-train the same model to detect certain words right live on the stage. So let's try this one, hopefully this works. Up, down, down, left, and right. Should use hand. Right. That was a surprise. Right. Right? Yeah, very good. Look at that. It spoiled my demo anyway. Get the idea. So, I had a default switch case in there. It wasn't detecting crap. All right. Let's continue with our slides. So, if you're more interested in seeing and not like a bunch of different ideas that people or community have gone and developed using TensorFlow.js, this is a great resource. AI.js rocks. It's basically a bunch of demos put together by Asim Hussain, who is a cloud developer advocate at Microsoft, but is really passionate about TensorFlow.js and where the thing is going like me. And I love his work in this space. So definitely go check this website out, and that's literally the URL. AI.js rocks. There are many different examples of people's work where they've developed something very different to what the example model repository has, and basically came up with this idea, and they put it on a GitHub repo, and it's appearing on that page. How are we going with time? Should be good to go, and let's see. It's actually showtime. So what I'm trying to do here, let me just duplicate my screen one more time. So we're gonna use the same speech command model and teach it a few words. So the words we are using today is takeoff, land, and flip. And these are the commands which I can send through to this drone using the SDK, which is exposed by Tello SDK. So what do we have here? We have basically what I'm doing here is getting this. I've grabbed a few of examples in a Google Colab where they're retraining a model, and I'll use those examples to retrain this particular speech command model. So if I do yarn watch here, and did I type something wrong? Yarn watch, and here we are in the. So this is the backend part. If I do npm start here, that kicks us the server where the server talks to drone, and I'm using a socket.io, which is basically a WebSocket, to send the commands from the front end into the server, which then is transferred to the drone. Now, currently I'm not touching drone for now. I'm just trying to see. So this is our demo page. I've put that double there just so you get entertained while I'm doing stuff. And it's because it wakes you up, so that's fine. Now I'm not basically connected to the drone, I'm just connected to the server. That's what you see, that status there. Now what we have here is 4 different buttons, and what we're going to do is the first one will get samples of my voice, and it just basically labels those as takeoff. The second one is land, the third one is flip, and the last one we just have to feed it some background noise so it understands what's happening. Now I was missing that background noise part, and it hit me really hard, and I'll show you why. When I started to train this model, it was recognizing all the words properly until I tested on the actual drone, and the drone took off. There was a lot of noise, and it wouldn't recognize any other command from that there on. So what I have to do, and you have to excuse me, I have to bring up a little YouTube video with a drone noise, just as a background noise, and feed it as a noise basically. So I just have that here. Let's start with the other ones. Take off, take off, take off, take off, take off, take off. Well, enough. So usually you need minimum of basically around 150 samples so you get around 60% accuracy. If the more samples you feed it, the more accuracy you get. Land, 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 flip, 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 flip. And now it's time for this one. You might cover your ears if you're sensitive to extreme noises. Alright, should be enough. Now we have to retrain this. So we've collected some samples and we're just running a basically training model on the pre-trained model, plus we're feeding these samples into it. It's going to take a bit of time. We'll wait for it. Now it's a good time to take care of the drone part. So what I have here is a really weird situation because this drone gets really hot, so I had to buy this to actually keep it cool. And you have no idea what excuse I used for my wife, because this is like, why are you even buying a fan? It's like anyway, I spent a lot of money on this to get this demo, okay? So the drone has a Wi-Fi, so I need to connect to that Wi-Fi now to be able to send commands to the drone. Now we reached about 64% accuracy. It means that some of my commands might not work like the first time. We might have to repeat it, but that's fine. We'll wait for this to get connected. Okay, we are connected now. Just gonna come here and type RS, which resets our server. This should basically gives us, yeah, we are now connected. If I now come here and say connect, it will connect to the drone. You see that green light there. Is it there?
Yep.
Yep, cool. Now let's try it. Take off. Take off. Flip. Land. Alrighty. Let me just kill these ones. I was just super nervous it wouldn't work. But I had a video recorded, by the way. I was ready. Alright. Let's go back. Cool. So this was basically I don't know, about half a day getting the drone bit working, about maybe a couple of days getting the pre-training model code set up. I haven't pushed this one to GitHub yet. I will, and I share the link afterwards. But here are some basically resources around TensorFlow.js and what you can do with it. There are a couple of blog posts there. The TensorFlow team just moved their blog off Medium, which is a really good thing. They're now hosting it themselves. So it's basically free. You could just go and check it out. And there are a bunch of collabs. And collabs' purpose is basically gives you a framework and a step-by-step instruction. So you can just go and explore stuff. And they give you code snippets you just can copy-paste in your editor of choice and get it working. Now here's the interesting part of this talk. We've got an assignment for you. Are you ready? Yes? I can't hear anything. Are you ready?
Yes.
That's better. Go have fun with TensorFlow.js. That's your assignment. There you go. And someone very, very infamous basically gave me a code. Myself. Now, with TensorFlow.js, possibilities are endless. Let's bring the fun stuff to web. Thank you so much for coming to my talk. I hope you've enjoyed everything, including the demo. And go have fun.